Okay, yes, Alia, Yasir, Harsha, am I audible to all of you?
Yes, ma'am.
All right. So in the last class, we had started with circular motion, and I have told you circular motion from all the lessons of your class 11th, we are going to do it together. So you have circular motion all together written with you. So I started with angular displacement. Angular displacement is basically the angle that is swept, right? The distance that is covered, but in angular terms. Displacement, you can say, but in angular terms means the angle that has been swept. This is the angular displacement. Now see, the way we have linear displacement, and based upon linear displacement we have velocity. What is velocity? Linear velocity. Linear velocity is rate of change of linear displacement, right? Rate of change of displacement is what we call as velocity. So what is angular velocity now? It's angular displacement's rate of change. When angular displacement is changing with respect to time, that is what we call as angular displacement, angular velocity. Till here we had done, yes, angular velocity. So it's basically the rate of change of angular displacement. Angular velocity, we represent it through the symbol omega, or it looks like W, but we call this as omega. So that is change in angular displacement over change in time, right? What is this? This is angular displacement over time. Fine. This is an axial vector, and I have told you the SI unit. Yes, radian. This is a very important SI unit because this is not commonly used. We usually have a habit of using meters and centimeters, right? So here we are using radian. So SI unit will now become C, radian for angular displacement per second. So radian per second. This is a common SI unit that is used. Now, the way in our motion in a straight line, we had the types of angular velocities. Remember, instantaneous, average, everything we'll discuss here also, just analogous of it. Just write down this. All right. So this was the basics of angular velocity. You just have to connect it with your linear velocities, linear displacement, which you have studied. So likewise, we had the types of linear velocities. You have average, you have instantaneous, depending upon non-uniform and uniform. Similarly here also. So initial portions of circular motions are very easy to understand. Like angular velocity, you have uniform angular velocity. Then you have non-uniform angular velocity. So in uniform angular velocity, both the magnitude and direction, they will what? Change or remain same? They'll remain same, right? And when we talk about non-uniform, then either of these quantities, you have two things with you. You have the magnitude and you have the direction. So either of these two things change, magnitude and direction. Now, see, when we talk about uniform, if suppose, let's say this is the axis, a particular angular velocity is, let's say, 2 radians per second. So throughout it will remain 2 radian per second only. That is what we call as uniform. But in non-uniform, it can happen that while reaching towards the end, it becomes 3 radian per second. The angular velocity increases, right? So how do you calculate it? Again, you have two methods. You have instantaneous calculation and you have average calculation. So similarly to velocity, when you have a particular duration, like you have 2 seconds to 4 seconds, 8 seconds to 10 seconds, 2 p.m. to 4 p.m., a particular time duration you have. For that case, you have to calculate the average angular velocity. And when you have a particular exact time instance, when you have to find out, then we differentiate it. So this becomes instantaneous angular velocity. Fine, then you have instantaneous angular velocity. Okay, Siddhika, no issues. If my voice cracks or you want me to repeat, then let me know that also. If your Wi-Fi is not working, and keep on typing. Instead of unmuting, you can keep on typing. All right, so these are the types of angular velocities: instantaneous, average, and the normal, regular. How do you calculate? Uniform, which we call. Now there is one relation between angular velocity and linear velocity. Linear velocity is the normal velocity which you have been studying, V, rate of change of displacement. That is your linear velocity. What is your angular velocity? Angular velocity is the rate of change of angular displacement. So whenever we have analogous terms, we have the relation also. Like you have force. Force's analog, rotational analog is torque. You will study later on. I think in cross product once I had discussed that also. So every quantity, every rotational analog has its relation with the linear one. So what is the formula for rotational analog? Suppose this is the axis, center axis, and R is the radius and a body is rotating, let's say with omega velocity. So at the particular point, let's say the linear velocity is V. Remember, direction of linear velocity will always be tangential. This is tangential. And the direction of angular velocity in the last class, I have told you it's an axial vector. So its direction is along the axis. If this is, let's say this is rotating, so direction will be along the axis only. So this is its axis. So the direction here is axial. Right? This is tangential, this is axial. So what is the relation? This relation is very important, class. Even sometimes this relation is used in your class 12th also. So it's very important if you remember this relation. All right, very important relation, and it will be helpful so much to you that in questions where even the quantities are not mentioned, you can use this and find out the third one. So velocity, it's actually cross product of omega and the radius. Now, what are all these quantities? Same thing. See, V is the This is the linear velocity. Fine, this is the linear velocity. This is the angular velocity, and this is the radius vector. This is the radius vector. So how can we write this? Omega r sine theta. That's how you will write. See, this is V is omega r sine theta. But most of the time, as you can see, in circular motion, what happens? Velocity becomes tangential. I have told you, the direction of velocity, it's always tangential. Linear velocity is always tangential. You have a tangential acceleration also because of this tangential velocity. So velocity is tangential. So if it is tangential, it will make 90-degree angle. So sine 90, that would become 1. So we have theta as 90-degree. So your velocity becomes omega r sine 90-degree. That is V is equal to omega r. Always remember, please, the direction I am again specifying. Direction of this linear velocity, it's tangential. And angular velocity is axial. That is along the axis. So the way you have no linear velocity, see, theta was angular displacement. So angular velocity will become theta over t. Similarly, you have angular acceleration, alpha. That will become omega over t. Same thing. It's just that analogs will keep on changing. There you had linear acceleration. Now you have rotational acceleration, which we call as the angular acceleration. Sine theta, because they are cross product. A cross B, remember Harsha?
Yes, ma'am.
A cross B gives you magnitude of A, magnitude of B into sine theta. That's how we got sine theta. Now, why is it 90 degrees specific? It can be any angle. Don't just remember that angle is always 90 degree. But in circular motion, we have velocity tangential, linear velocity tangential. If you have a different case, not a circular motion case, where velocity's angle is something else, you can take the angle. But right now it is perpendicular. See, omega, this is the axis, and radius vector will be like this. So that's why we have 90 degree. Till here you people have written, no? From here noted down. Yes, class. So this question says, a body moving on circular track completes 10 revolutions in 5 seconds. The radius of the track is given to you 2 meters. You have to find out angular velocity and linear velocity. So firstly, C class, when you have revolutions written, one revolution, this is equal to 360 degree. This is equal to 2 pi radian. This relation, please remember for your circular motions, because most of the questions these are written in terms of revolutions, because you have your SI unit as radian, so you have to convert it all the time, right? So one revolution is 360 degree, that is 2 pi radian. Now, if you have 10 revolutions, so now you know what is your answer, 20 pi radian. So what is delta theta? For 1 revolution is 2 pi radian. So 10 revolutions will become 2 pi into 10 radians. So that becomes 2 pi into 10 radians, that is 20 pi radians. So what is omega? Omega is change in angular velocity by change in time. So what is the value of delta theta? 20 pi. And how much time? 5 seconds, I think. Yes, in 5 seconds. This is 5 seconds. So that becomes 20 by 5, which is 4 pi radian per second. If you want, you can write down the proper value of pi also, 3.14. So this will be something 12.56 radian per second exactly. So this is the angular velocity. Now we have to find out the linear velocity, but for linear velocity you don't have to do separate calculations. You have the radius with you. Radius of the track is given, 2 meters is the radius, and you have angular velocity also. So just use the relation which we have studied. For the second part, V is equal to omega R. Omega is 12.56, radius is 2. So that becomes 25.12 meter per second. This is the answer. This is the answer for the first part. This is the answer for the second part. So whenever you have angular velocity with you and radius, try to relate it with the following relation. Question you people have written, I think. Okay, I'll show the question. Fine. Note it down. Some more questions we will see. See, here you have to calculate the angular velocity of the rotation of Earth. So in one rotation, if complete rotation occurs, one complete rotation, so what is the displacement covered? Can anyone tell me? If displacement, if one rotation is being covered, so what should be the rotation?
Zero.
How much, Harsha?
Zero displacement.
Complete circle, that is 2 pi radian. See, if the entire angular velocity, let's say this is some angular velocity omega. So in one rotation, change in displacement, this will be 2 pi radian. Now time what we'll take in one rotation, what is the time that it takes? In one rotation, what should I put the time?
24 hours.
Yes, Harsha, and are you answering? In one rotation, what should I put? 365 days.
24 hours.
24 hours I should put. See, time period will become 24 hours. So that is hours, I have to convert it into seconds. So that becomes 24 into 60 minutes into 60 seconds. Just check whatever is the exact value. I do not remember this. So this becomes 2 pi divided by 24 into 3600 radian per second. This is the angular velocity of Earth. Note it down. One more question now we'll do based upon instantaneous. Note it down first. See a very basic question from non-uniform circular motion. Uniform circular motion afterwards we'll do in detail. Briefly, we have already discussed. See, theta is given to you. That means angular displacement is given. Angular velocity is 0 to 2 seconds, and at t is equal to 2 seconds we have to find. So first one is you have a duration 0 to 2 seconds. Initial time to final time 0 to 2 seconds. So omega is delta theta by delta t. In the first case, you have 2 times. See, what is the final theta? Final time is 2. So put t's value as 2. Right? What is the final time? 2 seconds. So put it as 2. 3 into 2 square plus 2 into 2 plus 1. So this becomes 4, 3. Then again 4, 16, then 17. So this is 17 radian. Then theta initial. What is the initial time? It's 0. So put 0 everywhere. 0 square plus 2 into 0 plus 1. So all 0, this becomes 1 radian. So what is the change in displacement? Final minus initial. Final time minus initial time. So this is 17 minus 1. Final time is 2 minus 0. So that becomes 16 by 2, which is 8 radian per second. We have done a very similar question in linear velocity. So this is we are doing, so that this is just C class. You will be able to handle all these questions, but those who are not able to handle these types of questions till now, it means you are weak with your calculus. Let me know if you still need extra classes of calculus, differentiation, integration. These are very basics. Yes, second part says at t is equal to 2 seconds, means exactly at t is equal to 2 seconds, you are calculating the angular velocity. So we have to differentiate it d theta over dt. So that becomes 3 into 2t plus 2 plus 0, 0. So this becomes 60 plus 2. Now at t is equal to 2 seconds, omega will become 6 into 2 plus 2, which is 14 radian per second. So one very similar question we had done in the linear one also, right? But this is angular. So a revision also of your calculus and revision also how to apply same thing in your rotations. This can come from your rotational motion also. You have a lesson, no, chapter 7. And this can come from your circular motion, from your laws of motion. So just study it separately. After this, we'll start with uniform circular motion. But before that, note it down. See, uniform circular motion. So briefly, we have introduced, right? What is a uniform circular motion? Now you have two things whenever we talk about vector quantity. You have a magnitude and you have a direction, right? So magnitude of, you have now linear velocity, two velocities are there. Linear velocity, angular velocity. So for linear velocity, you have magnitude and its direction. For angular velocity, you have magnitude and its direction. So we'll be talking about all these quantities. Now see, angular velocity is at the same. This is tangential velocity. Let's say the velocity is 2 meters per second. Fine. For uniform circular motion, throughout the velocity's magnitude should be 2 meters per second. This has to be 2 meters per second. All right. Now, magnitude of linear velocity is constant. Direction of linear velocity can change. See, direction is changing. Here it was pointing towards the right. Here it's pointing downwards. Here leftwards. Here again it is pointing upwards. So direction is changing, but magnitude is remaining the same. This is regarding the linear velocity. Fine. Then come to angular velocity. Angular velocity is magnitude is also constant and direction is also constant. This is located from the center, whichever is the position vector. Because its direction is along the axis and through the axis it remains the same. That's why we have no differences. But we have different types of accelerations. Now, when the linear velocity changes, because its direction is changing and its magnitude is changing, just in case if its magnitude changes, then you get tangential acceleration. This is the acceleration. See, this is tangential. This is the acceleration when the magnitude changes. We get linear acceleration. This is because of change in the magnitude of tangential acceleration. Now, because the direction is also changing, we have the direction also changing. Direction is also changing. So here we have, this is one direction, this is one, this is one, this is one. So we have an acceleration along the radius and towards the, along the radius and pointing towards the center, which is known as the centripetal acceleration. This is because of the change in direction. This is because of the change in direction. Now coming to the magnitude of it. So direction is, see, remember 2 points for the direction. This is along the radius and towards the center. Along the radius and towards the center. So centripetal acceleration is v squared divided by r. This is the formula of it. V squared divided by r. Its relation with the linear velocity. What is v? V is the linear velocity and r is the radius of the circular motion or radius of circle. Sometimes omega is also given. So we know what is v. V is equal to omega r. Put in here. This becomes omega square r square by r. So acceleration becomes omega square r. This is also used where omega is angular velocity. Note down this part. We'll solve some questions from this. This is the new topic. This type of question from this we haven't discussed. Previous we had seen certain from your linear ones, but this is the uniform circular motion. And uniform circular motion will be specified in the questions. Fine, note it down. See class, this question says that a body is moving on a circular track with velocity 10 meter per second. Radius is given to you, angular velocity you have to calculate. So angular velocity, this you can even do it, solve it mentally without actually writing your answers. Omega will be V by R, velocity is 10, radius is 2. So your answer is 5 radian per second. That's it. Second part says centripetal acceleration. So centripetal acceleration, this is V square by R. So just one more 10 over here, that is 10 into 10 by 2. So that becomes 100 by 2, which is 50 meter per second. These questions look basic and they are also very easy to calculate, but they do come in the exam. Note down this.
Ma'am, could you scroll up?
Ma'am, what would be the SI unit for angular acceleration?
SI unit. See, radian is for theta. So when we have omega as d theta over dt, this becomes radian per second. And then when you have angular acceleration, that becomes d omega over dt. So this becomes radian per second square. Like we have no meter per second square, meter per second, meters, similar. One more thing, class, how to identify whether you have to use angular acceleration, tangential acceleration, centripetal acceleration. Because till now, 3 types of accelerations I have named. One I have named as centripetal, one as tangential, one angular, one linear. So see, when magnitude is variable, velocity's magnitude is changing. I have told you know the type of acceleration that comes because of change in magnitude. So that acceleration will only come, that is tangential acceleration. When direction is variable, I have told you that direction changes causes centripetal acceleration. But when magnitude of omega changes, d omega over dt, which acceleration was it? Right now I was telling it to Harsha, that was angular acceleration. And if magnitude is constant, magnitude is not variable, so will you have any acceleration in your system? There won't be any acceleration in your system. No acceleration present. All right, note down this for non-uniform circular motion. These points are important. Note it down. Please text me done once you have written till here. All right, if you have completed, you people can leave. In the next class, we'll continue from here. We'll try to complete circular motion now. Thank you so much, class.
Thank you, ma'am.